Hello and welcome to this lesson on indirect or inverse proportion. If you put today's date, title and have a go at the do now question, which is related to what we did last lesson. So C is directly proportional to the square root of y. Hopefully you wrote down that C with the proportionality sign. So it's directly proportional to the square root of y. So here, okay. This then gives the formula that C is equal to some constant of proportionality multiplied by root y. This is something we just need to learn to write down. Then when C equals 12, so we've replaced C with 12.8, y is 16. So 12.8 is equal to k multiplied by the square root of 16. Now we know the square root of 16 is 4, so this will give me 4k on the right hand side. So 12.8 is equal to 4k. If I divide by 4, that gives me that k was equal to 3.2. Putting that back into the formula, that gives me then that C equals 3.2 root y. So that's the answer for part A, express C in terms of y. Now for part B, we've got to find C when y is equal to 400. So replacing y with 400 in here, we get 3.2. Remember this is multiplying, multiplied by the square root of 400. Now the square root of 400 is 20, because 20 times 20 gives me 400. So if I'm going to multiply by 20, now this was a non-calculator, so if you're going to do this in your head, I'd probably break this down into multiplying by 10 and then multiplying by 2, which will give the same result as multiplying by 20. So 3.2 times 10 gives you 32, and then doubling it will give you that C is 64. So in this lesson we are going to look at inverse proportion. So we're going to solve problems this time where variables have an inversely proportional relationship, and we're going to work out the constant of proportionality. So our success criteria for today's lesson, our bronze objective, as I've just said, is to solve problems where variables are inversely proportional or indirectly proportional. Our silver objective is to work out the constant of proportionality, just like we did when they were directly proportional. And again, our gold objective, we're going to recognise graphs that show inverse or indirect variation. So what is inverse proportion then? So there is inverse variation or inverse proportion between two variables when one variable is directly proportional to the reciprocal of the other. That is, the product of the two variables is constant. So really all it means is that this time as one variable increases, the other decreases. So when we looked at Mo Farah and we looked at his speed increasing, his distance also increased. This time we're going to look at variables whereas one thing increases, the other decreases. So for example, the faster you travel over a given distance, so the faster the speed, the less time it would take. So if we were going to look at Mo Farah again, the faster he travels, actually his speed will decrease. It will take him less time. So for that, there is an inverse variation between speed and time. In other words, speed is inversely proportional to time. So to write that, so when we did directly proportional, so speed was directly proportional to distance covered. This time, speed is inversely proportional to the time it takes. And what changes is we still write the constant of proportionality symbol, but we end up with the reciprocal of the time, 1 over t. And this becomes the equation, so we still have a k as our constant of proportionality, but it becomes a division this time. So we have to learn that inverse proportion, so S is inversely proportional to t. gives rise to the formula S equals K divided by T. Instead of, when we had direct, it was S equals KD. We were just multiplying. So now with inverse proportionality, we've got 1 over, so it's the reciprocal of the variable, which gives rise to this formula S equals K over T. Now we can rearrange this, and we will look. So if we multiply up by the T, we get the constant of proportionality when it's inverse just by multiplying the variables together. We'll look at this in more detail. So let's have a look at an example. So M is inversely proportional to R. So straight away we would write down M. We use the proportionality symbol again, but instead of just writing R, we will have the reciprocal of R. We will have 1 over R. And this then gives us the formula that M is equal to K, our constant of proportionality goes on the top, divided by R. Then, just like before, it gives us if M equals 9, R equals 4. So if M equals 9, R is equal to 4. And to always get K, we just need to multiply up by the 4 because it's the opposite of division. So K will be equal to the variables multiplied together. So we would get that our constant of proportionality is 36. So this gives me then, replacing that into our formula as we've done with direct, M is equal to 36 over R. And that is our formula. So that is expressing M in terms of R. Now we can use this for part A. Calculate M when R equals 2. So replacing R with 2. So 36 shed by 2 will give me that M equals 18 for this part here. And for part B, R when M equals 3. So going back to our formula, if M is 3, we've just got it this way round this time. So if we multiply up by R, we'll get that 3R equals 36. And dividing by 3, we would get that R is equal to 12. So now, if I just get rid of my working out and have a look at the textbook answers. Also, it means you can pause the video and copy anything down that you want to. So step 1, we set up the proportion statement. So M is inversely proportional to R. Then we set up the equation. So M equals K over R. Then since M equals 9 when R equals 4, putting those in like I did before, we multiply it by the 4. So we get that K equals 36. So this was our formula that we had. M is equal to 36 divided by R. So if R equals 2, replacing that into our formula, we get that M equals 18 for part A. And for part B, remember it was the other way round because M was 3 this time and we needed to find R. So multiplying up by R gives 3R equals 36. Then if we divide by the 3, we get that R equals 12. Now let's have a little look at some quick fire questions. So I want you to think about the first thing that you would write for each of the scenarios listed. So if you want to pause the video and have a go and have a think, and then when you're ready to look at the answers, resume playing. So as a reminder then, for directly proportional, it's K times the variable. If it's inversely proportional, it's K divided by the variable. So for Y is directly proportional to X, hopefully you would write, so Y with the constant of proportionality symbol X, but we've got to remember this gives us the formula Y equals KX. So for Y is inversely proportional to X, we would get Y equals K over X. For Y is directly proportional to the square of X, we'd get Y equals KX squared. It's not over because it's not inversely proportional. This one, Y is inversely proportional to the square of X. would give us, square root of x would give us y equals k divided by the square root of x. Y is inversely proportional to the cube of x. This would give us y equals k divided by x cubed. Y is proportional to the cube root of x. This would give us, now it doesn't say inverse here, bit naughty, it should say directly. So it's y equals k times the cube root of x. Don't be fooled, this looks like it's k cubed times the root of x, but cube root of x, this is k times the cube root of x here. And then here, they've used the y with the constant of proportionality of 1 over x cubed. Just remember this is inverse proportionality and it's y equals k over x cubed. So let's have a look at some worked examples. So I'm going to go through these ones and then it might be an idea on the next screen to pause the slide and have a go. So y is inversely proportional to x. So straight away, hopefully you write down y with the constant of proportionality symbol, and it's the reciprocal of x because it's inverse proportion. This then gives the formula y equals k over x. So now when x equals 6, y equals 8. Remember, to get k, we're just multiplying. So when y equals 8 and x is equal to 6, so multiplying up would give me that k is equal to 48. So I get the formula y equals 48 over x. And now we can use this to answer the question. So find y when x equals 9. So x will be 9. So it will be 48 divided by 9. You would need to use a calculator on this one. They round to 3 significant figures, but 1 or 2 decimal places would also be appropriate. So you should have got 5.33. Let's have a look at this one. B is inversely proportional to the square root of A. So B, our proportionality sign. Now because it's inverse, it's going to be 1 over, but this time it's the square root of A. And this isn't very good, is it? This then gives us the formula B is equal to K over the square root of A. So now we can use the information we're given to work out the constant of proportionality. So when B equals 10, A equals 4. Now remember, it's the square root of 4 this time. So we're multiplying 10 by the square root of 4 to get K. Remember, the square root of 4 is 2. So in this case, K is 20. So my formula is B equals 20 divided by the square root of A. So now I'm going to use this. So find B when A equals 25. So replacing A with 25. So this will be 20 divided by the square root of 25, which will be 5. So this will be 20 shared by 5. So hopefully, yeah, we get an answer of 4. So the difference between these two questions, this was just inversely proportional to x. So it was x on the bottom, multiplying the variables to get the constant of proportionality, and then using the formula to work out what y was. This was inversely proportional to the square root of A, so making sure you've got that square root of A here. When you're finding your constant of proportionality, we had to do 10 times the square root of 4. Get a formula in the same way and then use it to work out what B was when A was 25. So now you might want to pause the video and have a go at these two questions before you resume playing. So this one, P is inversely proportional to V, so this would be 1 over V, which gives us the formula P is equal to K over V. Then substituting your values in, P equals 5 when V equals 8. So multiplying these together, I would get that K is equal to 40. So this gives us the formula P equals 40 divided by V. So finding the formula in terms of V, this is where this comes from, P equals 40 over V. Now calculate the value of P when V equals 2. So this just means replacing V equals 2 into here. So hopefully you've done 40 divided by 2 and got the value of P to be 20. Next question, H is inversely proportional to the square of R this time. This would mean R squared. So this would give you the formula H equals K over R squared. So let's input these values in here. So H is 3.4 when R is 5. So 5 squared is 25, so doing 3.4 multiplied by 25, that would give us that K is equal to 85. So K equals 85, and popping that back into our formula, we get that H equals 85 shared by R squared. So now we can use this. It asks us to find the value of H when R equals 8. So I can replace R with 8 in here. So I need to do 85 divided by 8 squared. So I need to do 85 divided by 64. So this gives us 1.328125, and then rounding this to 3 significant figures gives us 1.33. Now it didn't ask to round to 3 significant figures, so you might have given 1.3 to 1 decimal place, or you could have given the 1.33, but you might have looked at it as rounding to 2 decimal places. So now recognising graphs that show inverse variation. So this one here, if it's inversely proportional just to x, this is what the graph looks like. Inversely proportional to the square root of x looks slightly similar. Inversely proportional to the square and inversely proportional to the cube. So here the gradient of these curves are steeper with the x squared, and you can see the x cubed gets even steeper. So let's have a look at a question involving one of these. So the graph shows the relationship between y and x. So we've got inversely proportional to the square root of x. So the graph tells us then when x equals 9, the y value is equal to 8. We've also got this formula here. So what it wants us to do is input when x is 9, y equals 8. And then we can work out what our constant, sorry, this should have been x, shouldn't it? We can work out our constant of proportionality. So when y equals 8, x equals 9, so this will be the square root of 9, which we know is 3. So our constant of proportionality will be 3, and 8 times 3, which will give us 24. So our formula is y equals 24 over the square root of x. So that's our formula. It didn't ask for that, but that then helps us to work these out here. So find the value of y when x equals 4. So putting x equals 4 into here, the square root of 4 is 2, and 24 shared by 2. So that would give us there that y is 12. Then the value of x the value of, I'm guessing this should say, the value of x when y is 1.5. So having 1.5 equal to 24 over the square root of x. So we'd have to multiply up here. So you'd get 1.5 multiplied by the square root of x is equal to 24. Then if you do 24 divided by 1.5, that gives you 16. So the square root of x is equal to 16. And then you would have to square it to get the value of 256. So let's have a look. Yeah. So they got the 12 there, and the same as we've just done to get 256 here. On to the exercise then. Again, like last lesson, it's entirely up to you if you want to pick a few of these questions to have a go at, or alternatively, you can go and complete the Hegarty tasks for this week, which will cover everything that we've been through. If you want to have a go at any of the questions here, I've popped the answers again, as usual, at the end. Good luck.